Hello, everyone, and welcome back. My name is Corey, and well, this is episode number 100. Never thought I'd make it this far, but or that it would take this long. But this is the series of episodes where I've been creating a programming language from scratch. This is a different type of episode. I'm not going to do any programming. I've had a lot of people ask, Corey, what is this thing that you're working on? And a lot of people have said, hey, I tried to watch a few episodes. And my first response is usually, I'm sorry. Because these episodes are, let's say, dense, and it's programming. It's live programming. I think it's fascinating. Other people do as well, but not as many as are probably thinking, what on earth is going on? So I decided to make this video, and the purpose of this video is to kind of explain what is this Tang thing that I've been working on? Why am I doing it, and how is it any different from any other language that's out there? That's what I want to address. And so because I don't want this to be a 2-hour video like a lot of the others are, we're just going to see if we can move through this quickly and for episode number 100. And let's see, I got to get my keyboard shortcuts figured out. First of all, like I said, this video is for people who also are not programmers. So for just a quick moment, I'll say, what do we mean when we say programming? And the answer is, well, first of all, you got to make sure that your mouse is responding. There you go. You have to start off with a reasonably well-dressed programmer with a graying beard of knowledge, or me a few years ago. Anyway, and your programmer will write code in some editor of some sort. It's just they write instructions. Those instructions then are turned into code that the computer can understand, and that's an important part about understanding what programmers do. We basically translate ideas, ideas and common language descriptions, natural wording descriptions, into exact sets of instructions, and we do that through the code that then gets turned into this language that a computer can understand, and then the computer executes it and hopefully does not burst into flames. But that's what programmers do. We communicate ideas about how to do things using very exact instructions. All right. How do we communicate those ideas? Those are our programming languages. And quite frankly, there's a lot of programming languages out there. This is not even the tip of the iceberg. These are just ones that I could find logos for. Some are old, some are new, some are borrowed, and evidently there's a lot of blue in this as well. That's the programming language landscape. And so you might say, so Corey, why are you even trying to write a new language, come up with a new language when there's all of these others? And the answer is quite simply, programming languages exist because they do something specific that another language doesn't do. They're all a method of expressing ideas to other programmers, but also to computers. But they have different features that they may handle data differently or make some things easier, so they're geared towards a certain type of task. And so if you know one language, it helps in learning. It helps you when you learn the next one, So it doesn't really ever make any sense to say, how many languages do you know as a programmer? Let's say English, that's all I know as a programmer. And then everything after that, it's like, well, how familiar are you with this new programming language? But okay, so if there's all these languages, why am I creating Tang? Well, for that, we have to say, what is a program normally? And if you can imagine that there's a computer up here in this area, and there may be a program running, and the reason I have this area is like this is the maybe a thread in it. If you don't know anything about threads, all that you need to know is that programs can usually do more than one thing at the same time. For example, if your word processor, you type something, it may do other things. It's not just drawing the screen, but it may be running spell check. It may be doing an auto backup. And if it needs to start an auto backup procedure, it doesn't want to all of a sudden your screen freeze and you can't do anything, right? So normally programs like this, maybe like program number 2, there may be a lot of threads that are happening at the same time, but we still think of them all as the same program that is running. Again, they're written in a programming language of some sort, but it's compiled into that form that a computer can execute. And so now, how does Tang fit in? Well, Tang solves a different problem. There's still going to be a program that's running, but actually, do I have my, yes, there we go. Tang is meant to be used as a library so there's a program and it will use Tang as a library to execute different scripts that may be user provided. So whereas in the original case with the well-dressed programmer with the graying beard writing code, that gets compiled and run by the computer. But what if you have something that needs to be written after the fact? That is where something like Tang will come in. So probably the easiest way to describe how it could behave is, let's give an example. So an example might be a game that has user-supplied mods. For example, I've got a game that I've got a little spaceship here and it shoots red bullets and it's aiming at a star. Why did I choose this? Because these are the shapes I could get in the presentation software that I'm using. But if you say, what happens when a bullet hits a star? And you want to leave that open. And somebody creates a mod, that is, they want to change or modify the behavior of the program. You can say, well, tell you what, if you will provide me a script that says when a bullet interacts with a star, what should I do? You, as the game modder, could then write what should happen. And maybe you'll write one that says, hey, if the star color is blue, then decrease the health by 20. You shouldn't have shot that blue star. But if it's yellow, increase the points by 15 and make the star smaller. And then if the star size is 0, remove it, give the player extra points, show them a message that says bonus, and play something that sounds like the Death Star going supernova. Yeah. But this is something that the original programmer didn't write. This is someone later on wrote. And it is just one script that gets run. So a good application for a language such as this, and now this is not the intent of this language, but I'm just saying one way of understanding it would be there's a program that exists now, but it wants to allow other people later on to be able to add functionality. And there could be a lot of different things. You could have a script that says, well, what happens when the game starts? Okay, we'll create stars of red and blue and yellow. And what happens when the player hits this key or this button on the controller? Should it create a bullet? Should it, put up a force field? Things like that. And so a language, it is a language, but it's a library like this, allows for that type of extension. So that's the first example. Another example, something that might be more akin to what Tang was designed for, was that, of course, it's called Tang, meaning T for template and ANG from language, ANG, language. This is meant to generate HTML, the end result being HTML from a template. So again, the Tang script is a template, and it might be that you're trying to generate a website or generate an email or something like that. And you say, hey, I've got this list of names. How should I display this to the user? And you want to give that off to a designer who's not a hardcore programmer, is not going to be working on all of the intricate stuff of the big program. They just want to worry about that little part. So they might write something like what we see here on the left. They say, well, this is HTML kind of and mixed in with the Tang script, but they'll say an HTML and then they want to cycle through all the names. And so the way that this Tang script would work is that when the main program, that is this right here, calls the script, it will give it the list of names. And then the template designer could then say, and this is what I want to do with the names. This is what I want you to kind of assemble. So interpret this script. And the output might be a list such as this. Now, it could go even further. You might say, well, how do each of the names get rendered? And that could be something as simple as there's another Tang script that gets run for each name. And it might be code such as, well, is the person who's looking at this an administrator? If so, let's not only show the name, but let's give them a link to edit the person's information. Or if they're not an administrator, just show them the name unless it's their name. And then they could click on the link and go to their own account settings. All these different things. But the point is that you could have one Tang script that takes care of a very small part of the program, and then the results from that are made available to another script that assembles a different part. And all of these little parts don't have to be known about when the original program is written. They can be provided later. So that has been the goal of Tang. So, I've said this before, Tang is not the main program. It is a library that allows you to extend another program that's being written. So it is a library, first and foremost. Each script that it runs, each one of these little boxes, is executed by itself, and you can give it information, such as that example of rendering a name. Well, which name should it render? Well, it's rendering Bob's this time. It's rendering Alice the next time. So on and so forth. Each script is sandboxed from the global scope, so it can't change what's happening in the main program. It's protected in that way. See what else? Limited access to the outside program. This is huge. Go back to the game example. If you were to allow the programmer who's writing that mod to do anything, maybe they do something malicious, like they say, okay, we're going to search the user's hard drive for password files or bank statements or anything else, credentials to log into a server or something. And then we're going to send it to somewhere else. Well, that means they would have to be able to do a file access and a network access. And if you just allow them to write anything in any programming language, they could do stuff like that, and it's dangerous. So you want to give them this sort of limited access script so that you can control what they have access to. So yes, so by default, if you use Tang, they can't read files on the hard drive, and they can't make network requests or other things, profile you, track your computer. But Tang can be extended. You might have a use case where you want them to be able to access something. Well, the way I've written it, you can add functionality to Tang and make it do stuff that I never thought about doing. And that's, again, why I designed it. I thought it'd be fun. But you can create and override the libraries. Okay, so in conclusion, let's go back to the original picture. We've got the well-dressed programmer with the slightly graying beard who writes code that gets turned into machine code that then gets executed by the computer. Where does Tang fit in? It sits on the computer. So the program that the well-dressed programmer wrote, when it goes up there, it includes the Tang library. And when it gets to the user's computer over here, it will execute a Tang script and do it as much as it needs to, right? That's the point. And so that is what Tang is. It's a library. Yes, it's a programming language. Yes, it's an execution environment. There's a lot of stuff I can go into. But that's what I've been building. And it's because it solves a problem that I wanted to solve. I thought it'd be fun, to write it. And you may say, Corey, okay, I understand, but I just can't get into it. That's fine. You're not hurting my feelings. I consider this like performance art. I'm doing it so that it will exist. Some people are going to enjoy it. And yes, I've already been getting messages on YouTube from people who say, this is awesome. I'm loving this. Or I wish I had seen this, back when I was taking a compiler's course. And that's the thing. This is a programming language that is a lot more sophisticated than most of the times you would ever write in a compiler's course. And yeah, I'm doing it because I think that it should exist. Is everybody going to enjoy watching it? No. But some people enjoy watching football and they're not playing football. They just enjoy watching it. Some people enjoy watching golf. Some people enjoy watching billiards. Some people enjoy watching darts. Some people are weird and they like watching programming. So that's what it exists for. But, moral of the story, if you've wondered what Tang is, that is what I've been working on. So I think I'm going to wrap up for episode 100. It's not going to be a 2-hour episode again, but I am going to be taking a break, or slowing down, I should say. I'm not going to stop the development, but I decided I wanted to try to put out one video a day, every day, 7 days a week, and I have done that for the last 100 days, while still keeping my full-time job and working, and while still doing church, and while still hanging out with friends and family. And how do I do that? Very little sleep is the answer. So I've got other projects that I'm needing to balance at the same time, even other recording projects. I'm going to be recording some stuff about piano playing, and specifically for church playing, because that's what I do. I can teach that, and so I want to record videos on it. I want to start recording videos of other pianists that are in the area that have never gotten to record before. And, well, I've got the stuff to do it, so might as well. So I'm going to be slowing down on Tang. I'm not going to put out a video a day, but I'm still going to be working on it because I have plans. I've got things I want to do. So, in conclusion, this is what Tang is. Thank you for joining me on the journey, even if it's just been out of curiosity of what on earth is this. Have a great day, and hopefully I'll talk to you in person sometime. Bye.